So we should be on page 14. You should also have your formula sheets out in front of you as well, because that's also going to be an important thing to have. We're going to continue talking about unit conversion today, but we're also going to do a different type of unit conversion. Okay? So today we're going to talk actually not about converting linear measurements, but we're going to talk about converting area measurements. Okay? So we talked a little bit yesterday, or maybe it was the day before. It must have been the day before, because yesterday we talked about the quiz. But we're going to talk a little bit about area today and converting area. So let's just discuss what is the difference between a linear measurement and an area measurement. What's the difference? What would we be measuring if we were taking a linear measurement versus an area measurement? Can you describe it for me? Yeah.
I'm not too sure, but is linear when it's like all even?
What do you mean by all even? Can you give me an example of something that you might measure if it was linear versus area? Yep. Perimeter would be linear. What might be an area measurement? What might be an area measurement? What is area a measurement of? Yeah, the space inside, flat space. So for example, like if you were wrapping a gift and you needed to know how much wrapping paper to use, that would be area, because that's like flat space. Okay? So far, we have been talking about how do we convert units with distance, with length. And today we're going to talk about how to convert units with area. Okay? So I wanted to start off with an example. Let's say you have a rectangle, and it is this wasn't working for me earlier. Let's see if I can do it this way. Let's say your rectangle is, and this should be going into your notes now, or sorry, your square rather, is 2 meters by 2 meters. Okay? What would the area of that square be? What's the area? Yeah. 4 meters. It's not 4 meters. Do you know what the units are for area? Yeah. Meters squared. Do you know why it's meters squared? It's because it's a square, but also if you think about this, for this kind of thing, we've got to go area equals length times width. Okay? Now, if you include the units in this formula, you're going 2 meters times 2 meters. Okay? If we arrange how we're writing out the numbers and the units, okay, that's going to become 2 times 2 times meters times meters. Do you see how we're multiplying meters by itself? Can you guys see that? Yeah? Okay, so that's why the meters are squared. Okay, and also, if the answer was 4 meters and you were communicating that to somebody, you would actually be communicating a length, not an area. So we've got to include that square when we're taking an area measurement to indicate that it is in fact an area and not a length. Okay, that's essential. And in this unit, I am going to be insisting that you include units in all of your answers. Okay, and so if you don't, you're not going to get full credit on a question if you don't have the complete units in there. Yeah. Okay, so here's the question. Let's say you wanted to convert this area into centimeters squared. Okay? So what would this be in centimeters squared? Okay, 1 meter is equal to how many centimeters? Look at your formula sheet. Yeah. 1 meter is equal to how many centimeters? Look at your 100. Okay, so how many square centimeters do you think this is? 400. How many people think it's 400? Yeah? Okay. Well, let's actually draw this out again. That's supposed to look exactly the same. I know my drawing isn't very good, but it's supposed to look exactly the same. So please use your imagination there and pretend those are exactly the same. Instead of writing this as 2 meters, let's write that dimension in centimeters. How many centimeters would the 2 meters be? 200 centimeters. And how many centimeters would this dimension be? 200 again. Okay, so area is length times width, which means it's 200 centimeters times 200 centimeters. Well, 200 times 200 is not 400. It's 40,000 centimeters squared. Yeah, okay? So we cannot use the length conversion factors to convert area. What we actually have to do is convert each of the side lengths first and then calculate the new area. Does that make sense? Sort of? One way of seeing it also is because 1 meter is 100 centimeters, it's kind of hard to see visually. But we could also see it, maybe I'll extend the page a little bit because I'm running out of room here, but we could see it, you know how 1 yard is 3 feet? It's kind of easier to see that way. So if you look at 1 yard by 1 yard, oh, sorry, I forgot.
Oh, okay.
Okay. Hold on 1 second. No, it's okay. Okay, sorry for that little break. Okay, so it's actually easier to see with yards and feet because the conversion factor is smaller. So 1 yard, oh wait, there we go, equals 3 feet. Yes, we're good with that? Yeah, so if we have 1 yard by 1 yard, that's the same as 3 feet by 3 feet. Does that make sense? Like 3 feet is the same as 1 yard, yes? Well, if you kind of drew in, well, this is 1, 2, 3 feet, 1, 2, 3 feet, right? And then you drew in little grid lines. That's actually 9 square feet. Can you see how there's 1, 2, 3, 4, 5, 6, 7, 8, 9 square feet? Yeah? Okay, so you can't use the conversion factors directly. If you actually wanted to use them directly, you could, but if you're converting from yards to feet, you have to multiply by 3. If you're going from 1 yard squared to feet squared, or from yard squared to feet squared, you don't multiply by the conversion factor, you've got to multiply by the conversion factor squared. That's how you would do it in one step. Okay? Now, a lot of people, though, forget about that. So unless you consistently do that correctly every single time and never make a mistake on that, what I'd prefer that you do is convert the individual lengths first and then calculate the area. Does that make sense? Okay. All right, so let's go and try some examples. Okay, Rebecca's planning to install sod in her backyard, which is 18.2 meters by 9.8 meters. If sod costs 28 cents per foot squared, how much will it cost to sod the backyard? Okay, so she's got this rectangular backyard. It's 18 meters by 9 meters, but the cost of the sod is in square feet. It's not in square meters. Okay, so if we want to figure out what the cost is to sod her backyard, we've got to figure out how many square feet is her backyard. Okay, so what I would start out by doing here, you don't have to, but I highly recommend it, draw a picture. Okay, so we've got this rectangular backyard, and the length of the backyard is 18.2 meters, and the width is 9.8 meters. Okay, now we need to have each of these dimensions in feet. So here's where you have to get out your formula sheet, and we need to know what is the conversion factor between meters and feet. What is that conversion factor? Yeah. Equals 0.3048 meters. Okay. Nice, okay. So we basically need to convert each of these individual lengths into feet. So we can do some proportional reasoning here, okay? So we've got 9.8 meters, and we want to know how many feet is 9.8 meters. So as soon as you say to yourself, how many feet, that means you're writing X feet. Is 9.8 meters over 9.8 meters. That's one side of the equation. The other side is going to be this conversion factor. Which of these two values is going to go in the numerator? The 1 foot or the 0.3048 meters? The 1 foot, because I've put 1 foot in the numerator on the right side, right? Or the feet rather. So 1 foot has to go in the numerator over 0.3048 meters in the denominator. Okay, now how do I solve that? Yep. So how do I isolate x? I'm dividing it by 9.8. How do I isolate it? Multiply, yeah. I can multiply both sides by 9.8. Okay, and then these cancel. Okay, so I'm going to get that x equals 9.8 times 1 divided by 0.3048. And that comes out to be? Yep. 32.50? 1.5, okay, thanks. And yeah, keep some extra decimal places because this isn't the final step, right? This is an intermediate step. Okay, so that's the one dimension. That's the width. Maybe I'll do the length over here. And once you've set up the width, the length setup is the exact same, except instead of the 9.8 in the denominator, you're going to have the 18.2 in the denominator, right? So I want to know how many feet, x feet, is 18.2 meters worth. I want to convert the 18.2 meters to feet. And then I've got to have that same conversion factor on the other side. So 1 foot in the numerator and 0.3048 meters in the denominator. Okay, and so the calculation is pretty much the same. You're just using a different value for the meters. Okay, so to isolate the meters, or the feet rather, here, I'm going to multiply it by 18.2 this time on both sides. Okay, so these guys are going to cancel, and then x is going to equal, what is 18.2 times 1 divided by 0.3048? Yep. 59.71. Okay. So that's the one dimension, and that's the other one. So you may actually want to write those in. So I'm just going to write them in underneath. So the 18.2 meters, that was 59.71 feet. And this was, what was it? 32.15 feet. Okay, now we can find the area. Now I'm just going to erase this stuff that I did earlier with the yard stuff because I want to write underneath here. So now I can find the area in feet. Okay, and I know there are my dimensions. Okay, so here's my x. Oh, I'm still in green. Oh well. Okay. Hopefully I'm in black now. Oh well. So if I want to get my area in feet, okay, it's length times width. And I know my length in feet is 59.71 feet times my width in feet was the 32.15 feet. Okay, yes. Yeah. And that comes out to be, I don't know, what is that? How much is that? Yep. 1,919.67 feet squared, right? Because remember here we've got feet times feet. So remember we need units. Okay, now here it says that sod is 28 cents per foot squared. Now, how many square feet are we going to have to buy here? How many square feet will we need to buy? That's the area of the backyard. How many square feet will we have to buy? What do you think, Daniel? What do you think? How many square feet are we going to need? If we just bought 1,119, would we have enough? Okay, but I'm not sure. I mean, we may be able to buy part of a square foot, but I would probably assume in this case that we'd have to buy a whole square foot. It doesn't say, you're right, it doesn't say that. So if in this question you just multiplied by the decimal, that would be okay. But I would probably assume that you'd have to round up, okay? If you didn't in this case because the question doesn't specify, that's fine. But I would say that you should assume that you should buy 1,920 square feet, okay? And if it were me doing this job, because I'm not super handy, I'd probably buy a little extra anyway, right? Now, each of these square feet costs 28 cents per square foot. The cost is it 28 or 29? 28. Okay, so how would we figure out the total cost? Yeah.
1920 times,
Yeah.
and the answer is 500, and 37.51 with 19.
Yes, we multiply them, and that comes out to 500 what?
537.51.
51. 51? Is it 51? Oh, did you multiply by 6, 7? Can someone check that?
I've got it on my calculator right here.
Okay.
I did it by 6, 7.
Oh, okay, yeah.
So it's 537.5094.
Okay. Can someone just check what it is 1920 times 0.28? 537.6, oh, and 60 cents. Okay. There we go. Okay, cool. All right. Next. Okay, so here's another question. Similar style. Cool Deep has been hired to lay terracotta tiles on a floor that measure 4.2 meters by 3.8 meters. The tiles are 9 inches by 9 inches and come in boxes of 12. First question is, how many boxes must he buy? He cannot buy a partial box. So here we get indication. That's good, right? This is much more clear. Let's deal with that first, okay? So his floor is 4.2 meters by 3.8 meters. Let's just draw that out first. That looks kind of square, but oh well. And the tiles come in little shapes that are 9 inches by 9 inches. So these are teeny tiny. Okay, 9 inches is less than a foot. Okay, so what would we have to do first here? Yeah, so that's one thing that we can do. The essential thing, though, is that we've got to convert them both into the same units. Yeah, so one thing that we could do is centimeters, absolutely. You could convert them both into centimeters. What's another option? What's another unit that you could convert them both into if you wanted to? Because centimeters is not the only one that you would have to do. You could do another one too. I can think of one other that would work. Look at your formula sheet and see, is there anything that you convert both inches and meters into besides for centimeters? Yeah. Yeah, so we're basically what I want to know now though is we have to convert these both into the same units. Centimeters is one option. What's another option? Yards? Can we convert centimeters into yards? Well, I'm not sure if there's a conversion factor for centimeters to yards directly. There's one that I can think of though, that I can see. There's one other. Can we convert inches to meters? Let's see. 1 inch. We could convert inches to centimeters and then convert those centimeters to meters. Yeah, you could do that. There's another one that I'm thinking of, which is feet. You can convert them both to feet, right? The reason why I ask this question though is because I'm trying to model for you guys, these are the questions that you should be asking yourself, right? What are my options? These both have to be in the same units. Where could I go from here? Okay, now probably I would choose centimeters as well, which is probably the instinct that you guys both chose too. Okay, so we need all dimensions in the same units. Okay, so the options, centimeters works, feet works, meters works. You'd have to go inches to meters, but you could do that. Okay, and as long as you pick one of those, then you're good. Now I'm just wondering though, yeah, actually no, this is, I like the centimeter idea, that's good. Okay, let's go with centimeters. Okay, so let's take some steps to get in that direction. Let's start with the floor, okay? How many centimeters is the 3.8 meters? 38? 1 meter is 100 centimeters. 380, yeah. So this is 380 centimeters. And what about the 4.2 meters? 420. Yeah, okay. So not meters, centimeters. Okay, so the area of the floor in centimeters is what? How would we figure that out? Yeah. Uh-huh. How are you getting this? Yeah, so you multiply the length times the width, so 420 centimeters times 380 centimeters, and that comes to 100,000. Okay. What are the digits? Yep. 1596 00. So let's think about this. This is the 600 part, and this is 159,000. 159,600 centimeters squared. Okay, let's look at one tile. So one tile is 9 inches by 9 inches. 9 inches into centimeters. So we want to know how many centimeters is 9 inches. Okay, so how many centimeters? As soon as I say that to myself, I'm going to write X centimeters is 9 inches over 9 inches. Okay, now what is the conversion factor between centimeters and inches? Yeah. 1 centimeter equals 0. Okay, inches. Okay, so we could use that. Well, what would go in the numerator then? Which of those two values would go in the numerator? The 1. And which would go in the denominator? The other one, right? 0.3937. 37, that looks like a 9. Okay, so to isolate x, what do we need to do? What are we doing to x right now? Yep, multiply by 9. Right. Okay, and then these cancel. And we're going to end up with x equals 9 times 1 divided by 0.3937. And that is, I don't know. You guys help me out with that. 22? 22.87? Point which? 0.86 centimeters. Okay, so that's how much 9 inches is. Now, if I look at that square, maybe I'll redraw it. Okay, so this is 22.86 centimeters by 22.86 centimeters. Okay, what's the area of that gonna be? How would you figure that out? Multiply them together. So 22.86 centimeters times 22.86 centimeters, and that comes out to be, I don't know, 400 something? Ah, 500. So 5, 8, let's say, centimeters squared. Okay, so we know the area of one tile, and we know the area of the whole thing. Okay, so the area of one tile is 522.58. The area of the whole thing, let's just maybe write this out over here. So the entire area is 159,600 centimeters squared. Okay, one tile is 522.58 centimeters squared. How could you figure out, oh, not 60, 600. How could you figure out how many tiles you need? If you need to cover this amount of area and each tile covers that amount, 522 point something, how would you figure out how many tiles you need? Divide, yeah, right? So the number of tiles needed is going to be the total area divided by the amount of area each tile covers. Which is, I don't know, how much is that? Yep. 305. Okay, so in this case, how would you round? 0.39, okay, even better. Tiles. In this case, how would you round? What would you round that to? 305 point, how many tiles would you need to get? 306. Yeah, you don't want you want to go down because then you wouldn't have enough, right? You want to go over so that you can cover the whole floor. So 306 tiles. That's how many tiles you need. Okay. Now the other complication is that you don't buy individual tiles. These tiles are sold in boxes of 12. And we want to know how many boxes do we need. Okay. So if the tiles are sold in boxes of 12, how would we figure out the number of boxes that we need? Yeah, divide by 12. So the number of boxes is going to be 306 divided by 12. Is that 25.5? Yeah, 25.5. Now we're told at the beginning that you can't buy part of a box. So here we need to buy 26 boxes. Okay, that is all part A. That's a lot of work. Okay, that's all part A. In part B, this is the maybe more simple step, we just want to know the cost of this, okay? Each box is 18 something. How much is each box? $18.95. Each box is $18.95. So the cost is, how would you figure that out? Yeah. $492.70, and you just multiplied those together. Yeah? Okay. So $18.95 times 26, and it's 492, right? 70. Whew, there we go. Okay, now if you work in this industry, you'd have to do this kind of stuff all the time. You get used to these kinds of calculations. Okay, so you guys now have 20 minutes, and your homework for today is just 2 questions. You can do it all. You can get this all done.